This tutorial we learn uh, how to use ANSYS CFD software in order to model uh, flow over the circular cylinder. First, we have to create geometry in ANSYS SpaceClaim. Then you have to create mesh model in Workbench, followed by simulation in ANSYS Fluent. Please note that there are three softwares are required. First, we have to create a geometry. Second is to create in meshing. For meshing, we are using ANSYS Workbench platform. And third is we are using simulation software. And for simulation, we are using ANSYS Fluent. That means we can learn basic of CFD software skill in 1 hour. And it is a very good tutorial for beginner as well as those who want to learn some basic command in SpaceClaim, meshing and simulation. Please watch this video tutorial at the end. This is the working space in SpaceClaim. Hence it is called as a SpaceClaim. At the center there is a X, Y, Z axis and it is a local coordinate system. At the center there is a XYZ coordinate system which is at the center of the grid plane. And this is used as a working space uh, and it is the local coordinate system, and the left bottom there is a global coordinate system XYZ. There is a box is there and it can be used to move or rotate the body. And at the center there is a local coordinate system and the left is the global coordinate system. Global coordinate system and local coordinate system both are different. Please note while creating the any geometry. On the left top there is the sketch mode. You can use to draw line, circle and square. And here there are some 6 steps to create the model. First select the unit, then draw the 2D plane, then click on view plane which is at bottom, and after that selecting this 2D sketch mode, then you draw the uh, uh, model as per drawing, and then view in the 3D mode option, then do the Boolean option. Please note we create the 2D model after selecting the sketch mode. And there are some options are there how to select geometry, how to select the plane. Plane is selected in such a way that the plane is coming normal to the selected axis. We take Z axis, plane coming normal to the Z axis. Here we have selected the Z axis and plane is normal to it, and plane is XY plane, and it is the sketch mode. On the sketch option you have to create a geometry. You can draw line, circle, whatever you want. Here there are some options are there: line, circle, square, some option like a trimming, a chamfer are also there. First we can draw the circle as per desired diameter. Once circle is created, then please note dimension. dimension can be empirical unit, it can be in a metric unit, and here we have to select the unit. Most people use the empirical unit. You can use the empirical unit. Empirical can be in inch, it can be foot or inches. Foot and inches is a pretty much common. Select it. After drawing circle, we can also draw a rectangle line, whatever you want. Please drawing it. And this is a 3D mode option is there at the bottom, first option. And once we select in 3D view, then the surface is created based on the closed 2D sketch, and this surface we can use to extrude. And here pull command is there. Pull command is used to extrude the surface. That means it is used to create the 3D model. And this is the command extrude in other software. And if you want to edit geometry, you can edit whatever you want. You can also make complex geometry, whatever you want. You can draw line, circle as per your dimension. Here circle is created. After that, this I am drawing square box. And here grid is created backside, and it is quite helpful to create 2D sketch. And we can use the trim command to delete unwanted line or curve. We can also draw the circle here. You can edit geometry whatever you want. Once a sketch plane is created, you can see those curves are enclosed. The surface is created. Surface is created by which is enclosed by the two curves. Hence, concentric cylinder is created. You may think why such cylinder is not created, but we can create it in separate operation. If you remove the inner circle, then a complete circle is created. Later we can also draw the circle. And because ANSYS SpaceClaim is very comfortable to draw the 2D sketch plane, and after creating a sketch plane view in the 3D view, and the surface are created, and we can pull whenever we want. Please select no merge. That means a separate 3D body is created. On the left bottom, here solid volume is created. This inner hollow surface we can fill using the some fill command is there, but it is not possible here because here only one curve is there. That means we can delete extra surface. And you can take sketch plane normal to the one surface cylinder, draw the circle, and then we can extrude and no merge, and select up to which plane we want to extrude that surface. And in workspace, we click here up to this selected surface. That means body will be extruded up to that surface. Similarly, we can also extrude other surface. And please note the 6 steps to create a geometry. You can also give a color to the surface. You can also give a color to the body as per the custom requirement. We can extrude the curve up to the next surface. For extrude, pull command is used. Please note that. Note that. And there is also option is the boolean operation is called combine. We can merge two selected body. First click on the first body, then click on the control, then plus option will come, and then select second body. That means two bodies are merged. And here option combine option is used to combine two body. It can be also used uh, to split one body from other. Hence, this combine command is very useful. If you want to extrude, extend the one surface, keeping with same volume, that you can extend the volume. Just select on the move command and select the surface and give the dimension of extrude. It is not. It is similar to extrude, and we can also move the selected body from one location to other location, whatever as per the our need. That means the SpaceClaim is quite easy. We can use the pull command, move command, quite easy. There are also options are there. Some mirror option is there. Pattern command is there. We can also split the body. We can also split the surface, and there are a lot of options are there. It is quite easy to do it. And here we can also take any sketch plane, whatever you want. You can make a geometry. You can also draw the circle, and that circle we can extrude in 3D mode using a pull operation. And if you select no merge, please select no merge, so that separate solid will be created rather than merging with existing solid. Here separate blue color cylinder is created outside, and you can also this edit selected solid using pull and no merge option. Here I am this pulling the body, that means extruding. And we can also edit radius of the cylinder. Please select no merge, so that this selected body will not merge with the other body. This way we can create whatever we want a geometry. And here selection option is there. If click on the plane of the global coordinate system, we can select plane. We can move the cylinder whenever you want. We can select a cylinder. We can move up to the center of the local coordinate system. That means the body is moved to the exactly to the to the center. And delete the cylinder part, because we are going to solve flow over the circular cylinder. We can also check connectivity of the volume. We can shift selected fluid volume into the to the mesh mode option. There are other options also there, like select to the fluid, move to the ANSYS workbench. But here I am moving to the ANSYS workbench mode. It may take the time. Before that, save the SpaceClaim file. it may take time to open a SpaceClaim file in workbench. Once we select on the workbench, automatically the geometry will be in the model will be in the geometry option. It is taking time because it takes time to understand connectivity with other CFD software. Then select the mesh mode when geometry will come. That here geometry ANSYS workbench mode is the selected. Initially it may show the some error. We can say okay, no problem, because we have not given the uh, name of the workbench file. It saves unsaved project. Here automatically our model will be in geometry mode option. We have to select the meshing option, and here is the also other option is the meshing option. Go to the component system, select on the mesh and drag from left mouse to the right side workspace. That means geometry meshing, both options are there, and then drag using from left mouse geometry from column A to column B, from geometry to geometry. They connect this line from geometry part A to part B using by dragging from left mouse. Use the left mouse, drag a line from geometry so that it will move to the part B for the meshing. Then select on the mesh mode, use the right click, and there is a edit option is there. And select on edit, and the model will be open in meshing option. It may take time to open in meshing mode. This is a workbench platform. We can save anytime. There are two saving options are there. One is in workbench platform. Other saving option is in this meshing mode. And this here meshing mode is open, and the geometry will be reflected in the meshing option. Select on mesh. Here meshing option are there. This is generate mesh. To create the generate mesh, here mesh, select on mesh, select physics for the CFD. That means we are going to solve for CFD. This is very important to create mesh for CFD. So select the CFD mode, and after that select the solvers Fluent, because we are going to solve for the plane only. This is the geometry is there, and you have to understand the dimension. This dimension help to give the cell size in the mesh. Now how to give understand dimension? Select the curve, the entire E command from the mouse, then you can see the dimension. This is the press after selecting the any curve, press command E, the dimension will be reflected. That means the dimension is 10 mm, and we can give size order of 1 mm. Element size you can give 1 mm, 2 mm. This is, and there is also maximum size is there, and it is a maximum size. Whenever you select the volume, it should be minimum size. It should be less than the maximum size. And here option is the generate mesh. Because first select the body and give the sizing, and here I am also selecting inflation layer. Inflation means is boundary layer, and boundary layer or inflation layer, select the volume, that is first body, then select the surface, and take a number of element 5, and this element will be created normal to surface. That means around this cylinder body fitted layer will be created. That means inflation layer will be created around this circular cylinder. Growth rate is coming 1.2, maximum layer 5, and then after that we can give name to the part. Right click, create name selection, select fluid air, and then OK. In name selection, the fluid air separate volume will be created. Then we have to give name of boundary condition. Same thing, select the surface for the inlet. Also select the top and bottom surface. Right click in name selection, give name symmetry. We can give symmetry for top and bottom. Then we can also give inlet condition. Inlet is given, and you have to give outlet. Inlet is given, symmetry is also given. We have to give inlet. Please understand flow from inlet to outlet. And this is the flow direction. Please note that. And this is the fluid volume. And its name is given. Only you have to give name of the outlet. Select outlet using right click. In name selection, give name as a outlet or outflow. That means names are given, and then generate mesh. You can select right click in mesh option, generate mesh. Mesh will be created. This way mesh is created. If you think mesh is too coarse, and here check the size. This size is a very less, and you can check the mesh quality. And yes, here skewness is a 0.79. That means it is around 0.8. Check the quality. Check quality is okay. That means we can use for the plane. And maximum skewness allowed for the plane is 0.98. That means this mesh is okay. And we can also give different sizes to create a mesh as per your requirement. Finally, mesh will be created. This is a fine mesh, and we can see it is good enough to capture the flow. And the boundary layer is also captured around the cylinder. You can save this file. That means save the project. Give the name of the project. You can say whatever you want. And give project name properly so that you can remember. This is the cylinder 3D, and this is the project file. Project file and meshing file names are different. The project is saved, that means both geometry and meshing are saved. And here option is okay, that means our meshing is okay. Meshing is okay, that means this meshing can be exported for the simulation. Please note this correct option. The next option is you have to import the geometry, and here we have forgot the name of the wall of the cylinder. Please check it. That means name is given, and we have to also give name of the side wall. This inlet is okay, cylinder name is okay, outlet is okay, top and bottom wall is okay, but we have to give name of the side wall. Here click here and give name side wall. This way side wall name is created. And after it you have to check the skewness. Please check the cell size, it should be less than 5,12,000. So for the academic version, so that we can export this mesh file. How to export this mesh? Please note that this how file can be exported. Here first and second steps are okay. Next we have to export file for the mesh in Fluent Solver. Here option is export. We are exporting file for the Fluent. Please select this process. We are exporting for the Fluent. Once we select export and save the file .msh mode, that means file will be saved in .msh mode. Please note this one while exporting the file. Export file, and we can save where we are going to simulation. We can select where we are going to simulation of this case. And we can give file name .msh. And here our file will be exported. And how we will understand our file is exported or not? That we can see at the bottom. At the bottom, a message will come, and click on the message. Here, the Fluent file has been exported successfully. This message will come successfully. That means our mesh is saved. We can close this window while simulating for the Fluent, because it may take more memory in meshing mode. Is better way to close this meshing mode and open ANSYS Fluent. And we can also check whether file is saved or not. That we can also check. And please check the file path. Here file it is saved, and file is saved cylinder 3D. And after opening in the Fluent option, open in the Fluent window. Fluent window, you have to open it using ANSYS Fluent simulation. Then we first step, that is geometry making, meshing are okay. Then third step is to create the Fluent. After selecting it, open the Fluent window, and please copy the path in copy path of the file, and please select for 3D mode, because we are going to simulate for 3D mode. And then double precision, that means it can allow up to 10 raised to minus 12 decimal. And here we are selecting one processor, that means it is the serial mode. If we are using more than one processor, that means it is in parallel mode. Please note that while selecting. Here we are using on laptop. Here we don't use for the parallel. That means we select serial mode, and please copy the file path on the first command box, and open the ANSYS Fluent. This is the solver. After geometry and meshing, we are opening third software is called ANSYS Fluent. And some more information is also available on website www.CFD Flow Engineering. Go to blog and read the article CFD Modeling of Flow over the Cylinder, and by clicking we can understand detail of flow over the cylinder. First geometry is created, and then meshing in ICEM CFD, and some CFD results are presented here for the 2D mode. And this is the meshing is created in ICEM CFD. Yes, mesh is very good, and ICF CFD it has a good local control over the meshing. Hence, mesh is pretty much better than ICES workbench. And this video is also available on the YouTube. And you can also understand details of the modeling, what are governing equation are used, what are boundary condition on the website. Safe results of flow of the circular cylinder are presented for the laminar and turbulent flow. For turbulent flow, results are also presented. Contours of velocity, pressure are also presented, and some screen friction factor is also presented. These are the vector plotted on intermediate line. First you have to draw the line, and then see the vector on this plane. We can see the wake region and how it is there. And you can also see website, subscribe the channel to get more video. And there is also YouTube channel is there. You can get more video on this related to the CFD modeling, geometry, meshing, and advanced topic. And there are lot of videos are there. You can get a lot of learning related to CFD, like CFD modeling of the cement queuing, CFD modeling of the battery, and CFD online is also conduct online lecture. After reading this mesh file, read this mesh file like in cylinder.msl. Read file in .msl mode, and after this click OK. And please note that here we are solving a simulation for simulation in 3D solver, and it is reflected on the top of the Fluent window. It is a 3D mode simulation, pressure based solver. File will be read. Here mesh size more than 5 lakh, hence we cannot read this file in academic version. We can go back to the machine, and we can make course. Other option is we can also modify the geometry in J direction, because flow is homogeneous. We can also go to the geometry mode option to select to minimize the size. We can make a mesh as coarse if you want to reduce the mesh size. And here mesh size is 9 lakh. We can reduce the mesh size by reducing the cell zone in Z direction. Just select the plane, please by using pull operation. That means this geometry is edited. Then again select on geometry, update from the source. Then generate mesh. And we can give less size so that mesh will be generated, and check the mesh size whether it is less than 5 lakh or not. Now it is also 6 lakh. We can also give some more size. Then generate mesh. That means mesh is created with less than 5 lakh. Still, there is chance for reduction. We can take some more size, generate it. Try to modify the size in order to get mesh size below the 5 lakh. There are some options are there to see the geometry mode, wireframe mode, mesh mode. There are some selection options are there for line, surface, volume, and please try to do it. Check the mesh size, check the mesh quality in the workbench, check the boundary condition before exporting for the Fluent, and try to save file with different name where we are importing file, because it is a readable. And here we are again saving this file. We can check the imported file whether it is saved or not. Edited file you can replace with existing file in order to download a multiple file. Then the file is saved successfully, and then again we can see in the plain window. And keep the same path. If path is not there, we can also copy paste the path of a file and start with the selected path. Then again read the mesh file. And here the file is opened on the serial mode, and here it shows the number of nodes. There's N0, N1. That means it is done. That means ANSYS Fluent license is available. It is a student version. It is used for the only student training. We can read the mesh file, and here file is .msh. Here select file .msh, and it is a 3D file, and file should be 3D. Please note that we are selecting .msh. mod. They select OK, and then Fluent solver read the geometry. It shows the number of node, number of faces, and it shows the name of boundary condition. And here done at the bottom. That means file has been read successfully. We can check the general setting. We can also check name of patch, inlet and outlet. And inlet, the arrow is toward the CFD domain, and outlet means arrow is away, and it also shows the number of the cells. You can also check the mesh quality, and mesh quality here is be around 0.2, and whatever it shows, it is an orthogonal quality. Here it shows the orthogonal quality is around 0.2. Please note that orthogonal quality is 1 minus skewness. That means skewness is 1 minus orthogonal quality. That means 1 minus skewness was 1.8. That means quality orthogonal quality is 0.2. And we can also check other parameter. We can also make a polyhedra in order to improve the mesh. Here tet element will be replaced by the polyhedra element. And if you want to save the mesh time for the mesh simulation, you can convert into polyhedra. And after polyhedra, we can also check the mesh quality. Definitely mesh quality will be improved. It may take time for the converting to polyhedra. That means polyhedra is completely done. And you can also check the unit. Then after that, we have to select the setup for the CFD simulation. First step geometry, second is meshing, third is the CFD simulation in ANSYS Fluent. We are using 3 different software. Please note that. And all basic steps you should have noted. And then they start for the Fluent setting. Go to in the model. Here energy equation means enthalpy transport equation. It can be for temperature equation. Other name is the enthalpy transport equation. That means enthalpy is equal to specific into temperature. That means enthalpy transport equation can be given into temperature equation. It has a steady term delta T by delta T, and diffusion term plus U bar dot delta T del T. Then right side there is the diffusion term is there. That means Laplacian term for the temperature. Please note all this in energy equation. You select energy equation, it is there, but here we are not solving. They select the turbulence model. Default is SST mega model, and this is the most versatile model for any industrial problem. And for the flow of the cylinder, SST mega model is popular. Select it. And there are also other model are there. And here we are solving time average equation. There is also LES model is there, but it solved only for the transient. Here RANS model, please note that it solve only time average equation. Each model has some basic model like, and that model you have to note it. And there are also some other modification are there, like low number correction. Then go to the boundary condition and check it whether they are correct or not. And here see the boundary length is a hex element, it is not changed into the poly. And select the boundary condition zone type. It will be reflector on the left side. Inlet is on the left side, outlet is on the right side. A symmetry on the top and bottom. And give inlet to the velocity inlet. You can give the mass flow rate inlet if you know mass flow rate. And mass flow should be normal to the boundary. You can define mass flow rate whatever you want. And there is also turbulent parameter. Here I have defined mass flow rate 0.25. Given the turbulent intensity as low, it is less than 5. I am also defining the viscosity ratio. Viscosity ratio is ratio of turbulent viscosity to the dynamic viscosity of the fluid. That is molecular property. It is 10. And these parameters are not going to the mean quantity of velocity and temperature which are being solved in simulation. Please note that. We can select any intensity or turbulent viscosity ratio. And there are also RANS model are there, LES model are there. And then next step is for other boundary condition. Outlet we can use the pressure outlet or outflow, but here outlet is far away from the cylinder. We can use outflow means zero gradient boundary condition. Here wall is keeping as a stationary wall, that means cylinder wall is a stationary. Here it is not moving. Stationary means velocity of wall is 0, that means moving wall is not there, that means it's stationary. Here roughness is also there, you can also define. Then select the material. Material is here as the density is as 1.2 around 1.2 kg per meter cube, and viscosity is in Pascal second, and this Pascal per second is the SI unit. And you can modify density viscosity as you want. And density based on, you can get a number. Here number is equal to density velocity into the diameter divided by this dynamic viscosity. Using these 4 parameter, you can define a number. Velocity you can define based on average velocity. Density we know. If you put 1 for density, velocity, diameter, and viscosity put 1 into 10 minus 5, then the number is 10 to the power 5. That means it can be become as a turbulent flow. Please note that for flow of the cylinder, flow become turbulent if the number is greater than 5000. And please note that this is a turbulent flow, and we are selecting turbulent flow. That means this is a correct. Then we have to select other numerical scheme, like a pressure velocity coupling. We can use a simple use for the steady state flow. Numerical scheme you can keep default if you don't know well. And here is some control are there for the relaxation factor. Relaxation factor I keep as it is. These are as per Fluent. And then you can set the residual in monitor section, and it should be below 10 to the power minus 6. If keep below 10 to the power minus 6, and then go to for initialization, standard initialization, and keep for calculation activity auto save put as a 500, and put maximum limited file up to 2. That means maximum 2 case data files will be saved after modification. Please note for saving of the calculation file, and we can save the case file. Please note that after setting the numerical scheme ANSYS Fluent, please save file. Dot case file save the only geometry and boundary condition. After initialization, run for total number of iteration, say 6000. Here run here calculate means we start iteration. Check the graph whether it is going at downward for mass, momentum, and turbulent quantity. If it's going downward, that means it is a converging. And check the trend. Here, we have given maximum residual trend minus 6. That means it is converging. It is as a simple flow. We can stop after certain number of iteration. Check it whether it is converged or not. To stop it, you can use a Ctrl C command. And here we can save the case data file. Please don't forget. And we can also see the result. If you want to save the file, you can also save it. And this save the file. And please take a section place in the result. Create a surface at the center of the Z, and check the velocity control on the middle Z plane. You can also check the pressure contour. Here pressure is changed to the velocity. That means here pressure is checked. That means pressure is high on the front side of the cylinder, and low pressure on the rear side. You can also check see mesh in wireframe platform. Keep wireframe platform so that you can understand properly where is the section plane is there. Z is a section plane. You can also check the velocity. Here you can also check turbulent intensity, and after that you can also save the case data file. And the case contain both information of geometry and boundary condition. Also check the convergence by checking the flux report. Your flux report is there. The difference between the mass flow rate at the inlet outlet is close to 0. That means simulation has been closed. That means you can save the file for the post processing. If you want to iterate, we can iterate further by using command it and value. Let it run for the further iteration till conversion, and after conversion you can save the case data file. This way we have learned ANSYS Fluent. Thank you for watching this lecture. Thank you for attending this lecture. For more information about CFD analysis of any problem using ANSYS Fluent and OpenFOAM, you can visit website www.com CFD Flow Engineering. It covers most of important topic for engineers, scientists, related to the CFD and flow engineering, and also covers topic for flow technology. Thank you for attending this lecture. God bless you.